question 1 on this third exam, we have to calculate the pH of a buffer solution. Anytime we're looking at buffer solutions, this is likely a situation where we need the Henderson-Hasselbalch equation. Henderson-Hasselbalch equation tells us the pH is equal to the pKa plus the log of the concentration of the base over the concentration of the acid. So in this problem, we already know the pKa. We're told the pKa is 4.76. But we have to calculate both the concentration of the acid and the concentration of the base. So we can start with acetic acid, which there's 12 grams of. We can calculate how many moles that is. 1 mole over its molar mass of 60 grams. So what we've written there will give us the number of moles of acetic acid. In order to find the concentration, we need to divide that by the volume. And so if we do that, on top we get that we have 0.2 moles divided by 2 liters tells us that the concentration of the acetic acid is 0.1 molar. Now remember, the concentration of the acid goes on the bottom over here. Now we know that the acetic acid has to be the acid here, and the reason we know that is, first of all, we could guess that from its name. It has acid in the title, but also the fact that it has an extra hydrogen compared to sodium acetate. For sodium acetate, we need to do the exact same type of calculation. 25 grams divided by its molar mass, 1 mole over 82 grams. That gives us the number of moles, and we can divide that by the volume to get the concentration of 0.15 molar. So we plug that in here. From here, it's just a matter of doing the math. We can plug that into our calculator. Now before we plug that in, one thing we should find is we know we have a higher concentration of the base than we do of the acid. And so if we get an answer that's smaller than 4.76, we know we've done something wrong. When we calculate this, we get a pH of 4.94.